says, given a set of distinct positive, again, please mark everything. It's saying distinct positive integers nums, which means all the values in the nums will be distinct, positive, and all will be them integers. Return the largest subset answer. Again, we have to return a subset, as in not the just size of the subset. We have to return the actual largest subset, such that every pair, which means if I have a subset of 1, 2, 3, 4, 5 elements, then every pair I and j of the element of that subset, every pair I and j should satisfy any of these. Either I, answer of I, this answer of I mod answer of j is 0, or answer of j mod answer of I is 0, any one of them. And if there are multiple such answers, multiple such largest subsets, please you can return any of them in any possible order you want. Now, as you can see in this, that my 2 divides 1, right? Again, if I take a subset including only 2 elements, 1 and 2, then my 2 divides 1, so for sure. And again, I just want all the pairs, and one of the conditions, either 2 my can divide 1 or my 1 can divide 2. From this only, you must have understood that a smaller element cannot be in the numerator of a larger element when we are doing a modulo. So for sure, a higher element modulo smaller element, if that is a modulo by 1, that's a good subset. So one good subset is 1, 2. Other good subset is 2, 3. Nah, because 3 mod 2 is not a 0. Other good subset is 3 and 1. So you can see that we have only 2 good subsets, and the largest subset size is just for us as a 2. So we can return any of them, and the same way it has all of them as good subsets. Aryan, how can you say that? Because if you take a 2 mod 1, that is true, that is, which means 2 mod 1 is 0, 4 mod 2 is 0, 4 mod 1 is 0, 8 mod 2 is, sorry, 8 mod 4 is 0, 8 mod 2 is 0, 8 mod 1 is 0. So you can see all the pairs I and j are covered, thus this is entirely a good subset. Now, one thing which you might have thought of as a brute force and tuition part, which you can tell the interviewer, is I can generate all the subsets. Now, you know, to generate all these subsets, what all you need, right? It is just generating all these subsets. To generate a subset, you will take or not take an element, it is 2 to the power n, and then you have to go and check that element. Okay, check that element, that okay, if that element, sorry, if that group or if that elements in that subset are actually satisfying my condition. So it can be O of n square, because you have to go and try for all the possible pairs, but then we can reduce that to O of n also, which we can easily see that like, although we will see this optimization later on in future, but yeah, we can optimize it to O of n. Just remember for now, but I'll prove that in the later part, but right now I don't want to spend time in this. So one thing we can do is, okay, we can still optimize to O of 2 to the power n into n. Still, maybe if we want, we can just keep it parallel computation, so maybe we can optimize it to, but still it is kind of having exponential complexity, which is for sure never work for us. So from the constraints we can see we can try O of n square for sure, because n is 1k and 1 to the power 6 will work. So now we will come back and read the every statement again and see that what we can derive from it. We wanted the distinct positive integers. Okay, we have the distinct positive integers. We want the largest subset. Again, remember, we want largest and we want a subset, and such that every pair answer of I comma answer of j of that element in that subset, it should satisfy the conditions which were answer of I mod answer of j is equal to 0 or answer of j mod answer of I equal to 0. Now every pair, and we have a subset, which means if it is a subset, so order doesn't matter for it. Order doesn't matter for it because it's a subset of some elements. And when I'm considering I have to go on for every pair, I can just say, okay, if this is the subset which I have formed, A, B, C, so I have to go on to kind of all the pairs. So I'll go on to B mod A, then because B mod A, I'll check, then, and as you have remembered, I'll check B mod A, or I can check A mod B. Again, that was vice versa. I can check a C mod B or a B mod C. I can check a C mod A or a mod C. So I can check a B mod A or a mod B. I can check a C mod A or a mod C. I can check a C mod B or a B mod C. Now, one thing is for sure, that from here I checked, okay, B mod A or a mod B. Now, out of these two, one will be for sure false. Why? Because one, if we compare two elements and two are different elements, so for sure, if I compare 2 and 3, I know both the elements are different. So 2 mod 3 will for sure be never equal to 0, which means 2 mod a larger value, let's say 4, it can never be equal to 0. It will always be, and again, remember, it's a positive integers, then will never be equal to 0. So from here I can just remove this entire half of portion. Although you can see I am just trying, okay, b to a c to b, then a c to h. So I'm kind of trying for all the possible n square combinations, but still roughly half of them, okay, earlier I was trying for 2 into n square combinations, then half of them I can actually remove, because I know only larger mod smaller value can be a 0. Again, I'm not saying it should be 0, it can be a 0, but smaller mod larger will never be 0. So the entire half portion is gone. Now how to remove? Okay, Aryan, by this we have seen, okay, we got to know that, okay, I'll just put larger by smaller, so I can simply say now that I will simply sort this out. So I will now simply sort, and out of 2 into n square pairs I'll only be doing it up to, and check for only the n square pairs. Now for this one thing, okay, now you will check for only n square pairs, which means these n square pairs you will check a b c. As you can see, b mod a, c mod b, and a c mod a, you will check. Now just a quick thing, a quick glance on what you are doing. You are doing a b mod a equal to 0, you will check. You will after that go and check a c mod b equal to 0, right? And then you will have to go and check for c mod a equal to 0. Now if you look back very closely, b mod a is 0, then I can represent my b as something as a into k, because a into k mod a will actually be a 0, right? So like this is how not cross works, but yeah, a into k mod a will be a 0. So I can easily say that I can represent my b as something as a into k, because I know that, okay, b mod a was a 0. So I can represent the same thing. I can replace this b by a into k. I can say c mod a into k will be a 0. If this portion is 0, then for sure c mod a will for sure be 0. Because if I am saying that 6 mod 6 is a 0, then 6 mod 2 or 6 mod 3 will for sure be 0. No. So one thing is for sure, that I don't need to go and check for all the n square pairs. Again, it's an extra optimization, but because you remember, it's an extra optimization. Why? Because you know that still you can try for all the n square pairs, because the question has given you a liberty of O of n square. But still, while we were thinking out loud, we figured out that, okay, it is not actually important to go on to all the n square pairs. I can just simply go on and I can just simply erase this, and I can only go on to consecutive pairs, which means if I have a b c, I'll go and check, okay, b mod a is equal to 0. If it is, then I can easily go and check a c mod b equal to 0, and I don't need to go and check a c mod a equal to 0, because if this portion is true and if this portion was also true, so for sure this portion is automatically true. Now, like, no worries, it's an extra optimization. Make sure it's an extra optimization, because the question gave us the liberty of O of n square by default. Now, and again, we will just drive in the entire part, no worries on that part. So now we have got that we can just simply optimize it to of n, and simply we will sort it down, sort the numbers down. We have the numbers in the increasing order, and that was the first optimization which we thought of. Next we thought of that, okay, we just only need to check the previous sorting. Because of sorting, rather than 2 into n square, I will only be checking n square pairs. But then I thought, okay, now rather than n square pairs, if I just compare only the previous values, then I don't have to go on to all the values previous, so as to make sure that what's a number, if something is divisible or not. So that is 2 operations or 2 hints which we have got so far. Now let's come back to our main question. We had this, we remembered, we will simply sort it down. So I'll simply sort it down, because we remembered what's the benefit of sorting. Now we had 1, 2, 3, 4 and 6. Now simply, whenever problem is there, simply land onto any one index. I will not say if you are in the very beginning stage, then it is good to drive on from the very beginning and write down every step. But if you are in a very moderate state also, like, okay, beginning and just post that step, then land, I'll always recommend land onto any index. Okay, I'll land onto any index whatsoever, and then start to find what how will you compute your answer, and what all things you need for the existing values to compute the current answer. So if I am at 4, my again मकसद नहीं बोलना है, your ultimate aim was find the largest subset of elements such that the condition is there. Condition, you remember, it is if I am at this location, I have to find the largest subset. Now largest subset, the condition was that I will have to have a j. Okay, my j can be here. All right, I just want my nums of I, mod nums of j should be equal to 0. Now you can see 4 mod 3 is not equal to 0. Okay, that is automatically gone. This is automatically gone. Then I can try for 4 mod 2, which means my j is here. Then my 4 mod 2 is a 0. Yeah, it is a 0. 4 mod 2 is a 0. So are you saying, Aryan, that 2 and 4 can form one subset? Yeah, it can form one subset, which is actually great. But ultimately you remembered you want to find the largest subset. So would not have been good that when you were telling us about ABC, then you were saying that okay, a C and a B can form a subset, but what about a B could have also formed a subset with someone else, let's say A. Then what? Then you can also have said, okay, your largest, right now you're considering only B and C, but you can actually go and try for A also. Then you can have a 3 size subset, which is actually larger. So which means for 2, if I would have stored in that what could have been the possible maximum length up till 2, so 2 would have said, okay bro, if you say, then I can make pair with my value, which is 1, and thus I will make a subset size of 2. And then you know that you can pair with me, which is 2, because 4 mod 2 is 0, and 2 knows that he had paired previously with 1, a simple pair, because it has now got a size of 2. Now I can simply say, okay bro, I'll only check you, and if I only check you give me, okay, what all maximum possible size you can make. And for sure, if 4 mod u value, which means 4 mod, let's say u value is A, if 4 mod A is 0, then for sure all these smaller values which it had made pair with will also be equal to 0. So now because of my 2 storing a value of this, how much maximum size he can make, I can simply say that now my size is a 3. So that's how we got to know. Now if we go and relate this, now by so far you must have thought of that what existing problem we are talking about. It is simply an LIS algorithm, longest increasing subsequence. And that is the wow factor I was referring in the very beginning, that okay, oh, it's a LIS problem. That is what you realize, but it is not a very visible thing. That's the reason I said it is a wow factor. Oh, it's a LIS problem, because it is not readily visible that it is a LIS problem. Now if you don't know what is LIS, please go and watch this LIS. Again, write the LIS by Aryan Mittal, you will get the video. You will get 2 videos, O of n square approach and O of n log n approach. Now for this video, O of n square approach is more than sufficient. But for the folks who are still wondering, Aryan, why can't I optimize it? Because you told us that okay, I can just try. I know I have to find the LIS is longest increasing subsequence, and in this problem also I know that my subsequence or subset which I have made will be increasing, because I will do a nums of I mod nums of j. Nums of j will for sure be small, so I know okay, it's an increasing subsequence with a condition that okay, nums of I mod nums of j is equal to 0, and it's a subsequence which is considerably equal to my subset longest, which means largest. So both the problems are actually matching. Increasing was replaced because of the fact that we want an increasing subsequence, because of nums of I mod nums of j should be equal to 0. So this is the only sufficient thing for you to watch. But again, if you don't know it, if you know and still if you're wondering, Aryan, why can't I apply my LIS n log n approach, then I have clearly explained in this video that why LIS n log n approach cannot be applied on these kind of problems. So if you have a doubt, go and watch this video. Cool. Now coming on, that we will simply apply LIS, that is more than sufficient. So now simply dry run, a small dry run which we will have. For sure, in the very beginning, again, LIS will store longest. Now it's simply an LIS algorithm. That's it. Longest increasing subsequence, which is equal to, again, longest increasing subsequence. It was largest increasing subset. increasing because we knew that we will do a nums of I mod nums of I mod nums of j is equals to 0. This is what we will do. Okay, now you have remembered it is exactly same. Now how we will build the LIS array? Simple. Firstly, LIS length will be 1 for sure. LIS length, minimum length, LIS length, minimum length for sure for every element will be 1. Now for this, he will go and check his back. Bro, are you divisible from me? Bro, he will say, bro, yes, I am. So he will just simply say, okay, my length is 1. Your length, which you have given the maximum length up till you is 1. So, okay, up till us, the length is 2. Simply, it will go on. 2, 3, it will try with 2. Nah. 3, it will try with 1. Yeah, I can. So 1 and 1 for 3. So length will become a 2. 4, he will try for 3. Nah. 4, and again, by default, the value will be 1 itself, which means the element 4 itself. But 3, he will try with 4. Because 4 mod 3 is not equal to 0. No. 4, he will try with 2. Yes. If yes is the answer, then okay, I will try to maximize it. So 2 plus 1. So he will become a 3. 4, like LIS maximum length will become a 3. And then 4 will try with 1. 1. Okay, 4 mod 1 is 0. Yeah, true. So 1 plus 1. So he will try to maximize this, but 3 is already more than 2. So he will not put a 2 here. Now for 6, a 6 mod 4 is not a 0. Okay, by default value is 1. A 6 mod 3 is a 0. Great. So the value will become a 3. 6 mod 2. Yeah, great. The value will become a 3, but I already have a 3, so no, please don't update it. 6 mod 1, great, a 0. 6 mod 1 is a 0, great, but value will be 2, so don't update it. So this is the LIS length which we have made. But if you make sure one thing, that in the explanation or in the question, we only didn't wanted the LIS length. We have got this length, but we only didn't want this length. We also wanted to get the subset, actual subset also. So one obvious thing which could have come to your mind is, Aryan, while you were building this LIS array itself, I will keep track of the answer also. Answer is nothing but the maximum subset size. For this, the maximum length is 3. I just want all these 3 elements. Right. So what I can do is, okay, I know the value was 1. So I can just put a 1 here. Okay, 1 value was here. The length is 1. So I have one element which is 1. Length is 2. So 2 will for sure be here. And then I was able to make a pair with this specific one. So I'll make a 1 here. Okay, great. Then this was a 3. 3 was already there. I cannot make a pair with 2. I can make a pair with 1. So while building the answer, which is the LIS length itself, I can just allot a 1 here. Okay. Because I could make a pair with 1. As I update my LIS length with the maximum value, I can simply get that specific vector from him and put in me in that vector. Which means for 4, by default, I had only 4. But then 4 mod 3, nah. 4 mod 2, So 4 mod 2, yeah. Which means I'll get this vector 2, 1, 2, 1. And then in that vector, I'll just push back the me element 4. So I'll just get this vector. As you can see, it is this vector. And then, okay, the next I can do is at this point 6, I am at this specific 6. I'll go on to 4. Nah, but right now I have 6. Make sure. Okay, I'll go on to 3. Yeah. So I'll get this vector 3, 1. Okay, I'll get this vector 3, 1. I'll push in me, which is 6. Okay, this is the vector. I'll go again. If I maximize my length, this length, LIS length, if I maximize it, only then I update my this answer vector. Okay, I'll get this specific 2. Although length is 3, but this is not maximizing. So please don't update it. Like, keep it as it is. So that is how I can simply solve it. But if you know, by default, LIS will take O of n square time, right? So time is O of n square. That is for sure. And that we can actually do also. That is completely correct. But because of this thing which we are building, it will take a space n only elements, and for sure for every element I can have a maximum of n space. So with this phenomena, I am taking O of n square space also. So again, you can do this. It's an optimization. Okay, still it will submit the code, but still, can you optimize it? Do you actually need to build the entire array at every point? No, right? Why can't? Okay, you know that you had the answer as 3. Can't you just store one fact that from where this answer 3 you got? I say, okay, the answer 3 I got in from this 2. from this 2, and I can say for this answer of 2, I got the answer from 1. So I can simply build the answer parallelly. Okay, from 4 I can go to 2, from 2 I can go to 1, and that is my answer. So to build this answer backwards, and for sure, one obvious way is to store the answer parallelly also, but I'll not show it because I know it will be taking O of n squared space, and I don't want to take the O of n squared space. So this part I will not apply. I will use O of n space, and for that I need to store from where I updated my answer. So for this value 3, where it came it from where it came in, like from where it got big. So 3, this value 3, it actually came in from this specific 2. If you remember, 4 mod 2 was 0. So in this value 2, I added a 1. Okay, the length will increase by 1 because for 2, the length, LIS length was 2. Saying, okay, 1, 2 are the elements. Now I am saying 4 is also coming in, which means the length has increased to 3. So for 3, the from where he should go to next, which means the smaller element will be this specific length of 2. So I can just parallel from 3 I go to 2, from 2 I go to 1. So same, this is number 4, go to number 2, go to number 1. So I just need to store this backward kind of like previous index kind of information. For every LIS length array, just store the previous index, which index I should go to, or the same way from which index I came on at this current maximum value. So I'll store an information called as previous index, saying that from where I came in at this location, which means the answer LIS length, how it got big. It got big because of some index at location 1. You can see it got big because of the index 1. Let's say 1, 0, 1, 2, 3, 4. So it got big because of the index 1 element. So I'll just simply, how I will do it, I'll by default make, let's erase everything. I'll by default make my previous index, let's say previous index, I'll by default make -1, -1, -1, -1, -1 as the previous indexes, because by default it's -1. Now, okay, for this one, there is no previous index, no worries, move on. For this 2, as you remember, the answer, again, let's build the answer also parallelly and also previous index also parallelly. So by default, the answer is 1 for every one. So 1, 1, 1, 1 is the by default values. Now, as soon as I was at 2, I go and I went back to actually 1 value and asked him, bro, can you please let me know the if you can actually improve my answer? He will say, yeah, bro, 2 mod 1 is 0, so I can improve your answer. So he can improve my answer, which means he will update that to 2. So I know who increased my answer. My answer was increased by index 0. So index 0 is the one who increased me. So my previous index is index 0. Same way, 3 mod 2 is not 0. Okay, 3 mod 1 is actually a 0. Great. If 3 mod 1 is 0, so I can improve your answer. One will say I can improve your answer for 3, and if he can improve the answer, great. I can simply go and I can simply go and try and say that okay, your previous index is actually a 0. For same for 4, he can go to 3, he can go to 2, yeah, he updated his answer. If he can update the answer, great. Simply say your answer will become a 3, and who updated the answer? Updated answer was by index 1, and that's how you can simply build this previous index. Now how you will find the answer? Simply, you know that this is the length of 3, this is the length of index of 2. That's it. So now you know that you wanted the largest subset. So you will take the largest length. You will start off with this index, which means element 6 you will take. Then you will go on to the index 2, which means index 2 I'll go on, which is this index. I'll take this value. Then I'll go on to his previous index, which is 0. I'll go on to the index 0. I'll take this value. I'll go on to his index -1. Okay, then I will stop. So this is how I have to go and try for the value, so that my space use will be only O of n. One array for LIS length, other array for your previous index, and that's how you can actually optimize your space. Cool. Let's have a quick glance. The code is exactly same as that of LIS. Exactly same. And again, please make sure I'm using a bottom-up code. And please, for the folks who don't understand the LIS bottom-up code, I have seen many people just stick to top-down code for no matter if it's a linear DP or not. if it's a linear DP, please get out of your bottom up code. Sorry, please get out of your top down code. There are many optimizations which can only be done in bottom up code, and it is very beneficial that you should be knowing bottom up code at least for the standard problems. Especially for linear DP, always. Again, for 2D DP I can say don't do it, but for the linear DP, always do the bottom up code for sure. I have seen many people just failing in interviews because the interviewer asks you to print the path of the DP. Like when I say path of DP, this is the path of the DP. And recently a friend of mine, he failed because he could not build the path of the DP because he never knew how to write the code in bottom up. Great. That's a worst you can do to you, and that's an attitude I have seen in people. Just they will say, okay, nahi, I only want the top down code. I don't even understand the bottom up code. That's what they have perception of themselves. But if you have the perception, please break it down right now, because you have to understand the bottom up code for sure. And again, especially for the minimum requirement is 1D DP at least. 1D DP you should be knowing bottom up for sure. 2D DP you can still skip it, but 1D for sure. Now coming on back, I will just simply keep track of my n as my size. Now this is my LIS length. Again, I name the same LIS length, longest increasing subsequence length. Same, just to not make sure that you disturb. This is the previous index, which will help me to get the final answer. And maximum length, because if you remember, I will start off my entire iteration by saying, okay, this is the maximum length at this specific index. Now start off with this value as 6, then go on to the previous index values. So it's a reason I have to keep track of the maximum length and the index at which I got this specific maximum length. Then I'll simply sort it down. Again, this is an extra optimization which you have done on top of the existing code. If you don't sort it, and still if you modify the code a bit, again, now many people will just simply come and say that, okay, I'll simply remove this and still it should work. No, it will not. No, it will not, because you will have to modify this condition also, that you should check both the possible pairs. Now if you sort it, then you will only have to check for just the previous value. Okay, if this is I, j will be for sure small. Now I'll go and try for all the possible i's, and for every I, I'll go and try for all the previous j's. Again, you can also do it. See, here I did it from 0 to I, which means I'm going increasing order in j. You can also do the same thing as I was saying explanation, from j equal to I minus 1, j is greater than equal to 0, and j minus minus. This will for sure work. And talking considerably, this is a better optimization on top of this code, because this will break out like much faster than this specific loop. So yeah, it's but yeah, both of them have the same time complexity. Now coming on back, we will have a quick check if nums of I, this is the only extra condition in your LIS algorithm, only extra condition. And then you will have check, okay, if the current LIS length of I, and from j you are coming on to I, right, with adding one more character, which was the nums of I. If this is more, which means you should update your LIS length of I, because you are at the index I. So I'll update the length, which means LIS index of length, LIS length of I, I'll update it and say 1 plus LIS length of j, and then I can just update that previous index of I also to my j, because I know that in the future I will have to build back my subset also. Now when this portion is done, which means for I have found the maximum. For I index, I have found the maximum LIS length. I will just have a quick check and update my maximum length of the entire array of nums, and say if the current LIS length of I, if it is more than the maximum length, then please simply update the maximum length, which is LIS of length of I, and also update the index also. This is needed because in the super end, I have to go and start from the maximum index. I have to go and start from the maximum index, maximum elements index, and then have to traverse back. So it's the reason I'm just storing that parallelly. Now when this entire portion is done, I am good to find the actual subset answer out. So I'll just make an answer as a vector. I'll say while my index is not equal to -1, because if you remember, my base by default everyone will be a -1, and it will stop here. I'll just simply push back the current index values and then find the previous index, and then assign to index, and then the loop will keep on going and pushing my nums of index values, and then simply return the answer. By this, you will solve it in O of n square time with the space optimization as O of n. So from brute force, which is exponential, we optimized that, and from that we went on to O of n squared time and space, and then from O of n squared time and space we went to O of n squared time and O of n space. Again, if you go back and remember, in the very beginning I told you that you can actually optimize this O of n squared to O of n. Now you remember, right? O of n square was the comparisons which you had to do. You can remove those comparisons by simply sorting it down, which is n log n, in the very beginning. That's a pre-computation in the very beginning, and then you can simply compare that parallelly in O of n itself. That was the optimization in brute force, but that is just for you to just know. Okay, the interviewer just might know that he can actually solve it, but I'll highly recommend don't speak those words here, because then it might feel that you actually know the answer. So just say, okay, the brute force is this, and then continue forward to your optimization approach, and then tell the ultimate, and then first tell the approach having the extra space, which is the O of n square space, and then ultimately go and tell O of n space. And that's how you can simply solve it. See you, bye bye, tata.